Okay, here's a problem where we want to graph this exponential, e to the x minus 3 minus 4. Find its domain, range, intercepts, and asymptotes, if any. Well, this we can get by first thinking about the graph of y equals e to the x, right? And so here's my y equals e to the x. So x-axis, y-axis, y equals e to the x. This is a point, of course, x is 0, y is 1. And I might notice its domain, range, and asymptote. So the domain here of e to the x is all real numbers. And the range here, well, our y values that we hit are the positive real numbers. We get close to 0 as we go over to the left, but we don't actually hit 0. And we do have this horizontal asymptote on which is the x-axis. We go off to the left, and that's the line y equals 0. Okay, so I want to start with this graph, and then I'm going to translate it to get this. So I need to talk a little bit about translations. Okay, so I have the graph of f of x versus the graph of f x minus h plus k. Okay. So basically it's going to depend on our h and k here, and basically for here, if h is positive, means we move the graph of f of x, we move right h units to get our new graph. Okay, if h is negative, then we move or translate left absolute value of h units. If k is positive, we move up k units. And if k is negative, we move down absolute value of k units, right? So this gives us our graph of this new function y equals f of x minus h plus k from the graph of just y equals f of x there. It looks like we're doing something different with our h's and k's here, but just as an aside, I could also write this as y minus k equals f of x minus h, and I could say I'm doing actually the same thing to both variables. So now what I want to do is want to think about our original graph here. We had here was our y equals e to the x, and then over here we want right in here y equals e to the x minus 3 minus 4. So h is 3 and k here is negative 4. So that means I'm going to move this graph here to the right 3 units and down 4 units. This x-axis now is going to become this line. If I move it down 4, y equals negative 4. That's going to be our horizontal asymptote. So my graph is going to look something like this for my new graph. So I'm thinking about moving this over to the right and up 4. And so I have this y equals -4 as my horizontal asymptote. What about the domain and range here? Well, is it obvious the domain here is going to be still all real numbers, right? Because I just have the same x values. But my range here has changed to, well, I almost hit -4, but not quite. -4 to infinity. So this means that we don't actually include -4, but all the numbers right of -4. So what's left to do here is we want to find these intercepts. We want to find this point and this point here. So I have to think about intercepts now. And for my intercepts, okay, so what is my x-intercept? Well, this is where y equals 0. We're on the x-axis. My y-intercept is where x is 0, right? And my original function here had y was e to the x minus 3 minus 4, right? So for my x-intercept, I'm going to put y equals 0 in here. I'm going to have 0 equals e to the x minus 3 minus 4. So that means that e to the x minus 3 is 4. So x minus 3 is ln of 4. So I'm finally going to get x is 3 plus ln of 4, right? So I have these implies. I just have that from logarithms. So my x-intercept, I'm going to have the point 3 plus ln of 4 comma 0, and this is roughly 4.386 comma 0. The y-intercept's a little bit easier. So the y-intercept here, what I'm going to do is I'm going to let x be 0. So I get y equals e to the 0 minus 3 minus 4, or e to the negative 3 minus 4. And so I get my point x is 0. I have e to the negative 3 minus 4, which is roughly, let's see if we calculate this, 0 and negative 3.95, right? So these are my intercepts. Finally, what I would do is I would graph this thing and see what it looks like. So maybe over here, let's see. So I have my y equals, I need to turn this on. So I have my y equals here. So I want e to the x minus 3 and then minus 4. I'm going to quit out of that. I want to see my window here. Well, my window should include all the points of interest, so I want to go down at least to y equals -4. So we'll try the standard window here, and then quit out of that. I'm going to hit my graph, and you can see that this has the behavior that we want. In fact, it's actually going to horizontally to this y equals -4 very rapidly. It's kind of going up sharper than what I thought it would. If we want, we can also check the x-intercept there, because the x-intercept, if I go second calculate, is a 0 of the function. So I calculate the 0 there. I move this to the right hand side of this, left hand side of the 0, right hand side, and I guess, and I get 4.386 roughly, which is, lo and behold, what we had over here, 4.386. So that looks good, my graph looks good, everything looks good, and that's all for this problem. Thank you.